Lesson 10.3, Arcs and Chords. So the first thing we're looking at is a circle with two minor chords. We have the chords F, G, and the chords J, H. If we know that these two chords are congruent, then we know that their arcs are congruent. And if we know that the arcs are congruent, then we know that the chords are congruent. The next theorem that we're looking at is if we have a diameter or radius of a circle, which here we have AB, and is perpendicular to a chord, then it bisects the chord. And if we know the other way around, we know that a diameter bisects a chord, then we also know it's perpendicular. Which is this theorem right here. If we know that a chord bisects another chord, then we know that the chord that is bisecting it is the diameter. And the last thing we know is that if we have two chords here, like FG and GH, and they're equal distance from the center, then the chords are congruent. We also know if the chords are congruent, then they're equal distant from the center. So for our first example problem, we're told that circle W has concurrent chords, which are RS and ST. They tell us that the measure of arc RS is 85 degrees. Well, since the chords are congruent, the measure of TV also has to be 85 degrees. Is a measure of RS, which is 85 degrees. In the next picture, we're told that the two circles are congruent. Both A and B are congruent. We know that the chords here are congruent. So that means that, we know that the arcs are congruent. So since the arcs are congruent, the chords have to be congruent. To solve for Wx, we would set the two chords congruent to each other. 7x minus 2 equals 5x plus 6. Subtract 5x from both sides. I would have 2x. Add 2 to both sides. I would have 8. Divide both sides by 2. I have x equals 4. And I want to find Wx. So Wx is 7x minus 2, which is 7 times 4 minus 2. 14 and 14 is 28. So that's 28 minus 2. So Wx is 26. And the next problem, we're told in circle Z that the arc WUX, which is this arc here, is 160 degrees. We want to find the measure of arc UX. Since we know that ZU is perpendicular, we know that it bisects here. So we also know then it cuts the chords into two equal lengths here. So the measure of chord UX would be half of 160, which is 80 degrees. The next problem brings in previous knowledge again. In the circle QS, the diameter is 14. Which makes the radius 7. We want to find VU, which is this right here. It's not a radius. To use it, to find it, I'm going to make a right triangle. So I'm going to connect V and R, which is a radius, and that's 7. We know that chord RT is 10 inches long. Since the diameter here bisects it or is perpendicular to it, it bisects it. So if the whole length is 10 inches, that means that RU is 5 inches. So we have a right triangle here, VRU. We know that the hypotenuse is 7 and one of the legs is 5. We want to find this length right here, which is VU. So we know that x squared plus 5 squared equals 7 squared because Pythagoras told us so. So go ahead and solve for x. So x squared is 49 minus 25, which is 24. That means that x is plus or minus the square root of 24. To simplify the square root of 24, 2 goes into 24 12 times, 2 goes into 12 6, 2 goes in 6 2, and then we're left with a 3. These two 2's would come on the outside. So it'd be 2 plus or minus 2 rad 6. So VU equals rad 24, which equals 2 rad 6 inches, which is approximately 4.90 inches. For the last problem, in circle R, we know that MN equals PO, so those two chords are congruent, which means that they're equal distance from the center. So RQ has to equal RS. We want to find RS, but since RQ equals RS, we can set up our equations. So 3x minus 6 equals x plus 8. 2x would equal 6 plus 8 is 14. So x would equal 7. So that means that RS equals 7 plus 8, which is 15. And that concludes the lesson for 10.3.